So we are already at week 5. Welcome. We are going to talk about two sections, 2.6 and 2.7. So 2.6, we're still solving equations. We're solving other types of equations, and there's going to be 4 different types of equations that we're going to solve in this section. So one type of equation we're going to solve are those with degree greater than 2. An example would be 4x to the 4th plus 8x squared minus 9x minus 18 equals 0. Now, the great news is we're going to solve these by grouping, which we did back in section 2.5. So just as a little reminder, we group the first 2 terms, we group the last 2 terms, and then we find the greatest common factor of each of those. So in the video lecture, you'll see us play that all the way to the end and get the solutions, but that's just a little highlight of how we're going to solve these, equations of degree greater than 2. There's another type that we will solve that what we call the quadratic form. They're not quadratic equations. They don't necessarily have degree 2, but we can force them into being quadratic. So an example of an equation that has quadratic form is x to the 4th minus 17x squared plus 16 equals 0. So it's 4th degree and it has 3 terms. It's not going to fit into this category. We're not going to be able to factor it by grouping and solve by that method. Instead, we're going to make this into a quadratic by using what we call substitution. Let's use u and say that that's equal to x squared. That means that if we square u, that's x squared squared, which is x to the 4th. So replacing x squared and x to the 4th with u and u squared, we get u squared minus 17u plus 6 equals 0. That's quadratic. We know how to solve quadratic equations. Now, we want to remember for these, we want to solve for x and not u. So once we get to that point in the equation where we know what u equals, we go back, replace the u with x squared, solve for x, and we've got it. The third type of equation that we're going to solve in this section are those with square roots, such as the square root of x minus 9 equals 8. And these, we don't really need to have any special method or technique. We can just solve for x directly by undoing the operations around that. So we have x trapped in the square root. We want to get x by itself. Squaring the square root of x minus 9 gives us x minus 9. 8 squared is 64. Add 9 to both sides. We get x equals 73. So the fourth kind of equation that we're going to look at are those that have absolute value. Let's define absolute value. It's not an operation or a function that we use very often. So absolute value gives us the distance away from 0 without the direction. So that means without the plus or negative, the positive or the negative sign out in front. So let's look at an example with absolute value, just having a number inside the absolute value symbols. The absolute value symbols are just these 2 small vertical lines on either side of a number or a quantity. So here we have the number 10 inside. Well, 10 has a distance away from 0 of 10. So just have to take away the absolute value sign and we get the absolute value. Now, the absolute value of negative 10 also has a distance away from 0 of 10. And the absolute value takes away the directional element of that negative. So the absolute value of negative 10 is 10. Now, we think of that as being positive 10 because there's nothing out in front, but definitionally, it is just raw 10, the distance away from 0. Section 2.7 is on solving linear inequalities. So we know what linear means. It means that the variable x has degree 1. So we have no exponents greater than 1. In our example, we can see that we've got degree 1. It's not an equation, it's an inequality. So that means instead of having an equal sign, we're going to have an inequality symbol. Let's first just go through what those inequality symbols stand for. The one that we have in this inequality is greater than. It opens up to the left. That tells us that it's greater than. Now, if we want to have it greater than or equal to, we add a little half of an equal sign underneath the greater than sign. Flipping the greater than sign around, we get less than. And adding half an equal sign, we get less than or equal to. So those are the 4 inequality symbols that are going to show up in this section that we're going to solve using. Now, the great news is that solving linear inequalities is almost the same as solving linear equations. There's 2 exceptions that we're going to talk about. We're going to go ahead and solve this inequality, and we'll talk about one of those exceptions. So we're wanting to get x by itself on one side of that greater than sign. So let's start off by subtracting 2x from both sides. We get 3x minus 4 greater than 1. And now add 4 to both sides. We get 3x greater than 5. And now divide by 3 to get that x by itself. The 3's cancel, and our result is x greater than 5/3. So here's our first exception to solving linear equations. This is not just one number that x equals. This is a set of numbers. It is the set of numbers that are greater than 5/3. This is one way we can express that number with the inequality symbol. In this section, we're also going to learn how to express that set of numbers using a number line, where we mark that value on the number line. It does not include 5/3. It doesn't have that little half equal sign. So we use an open point, a circle, to say that number's not included. But we want all numbers that are greater than 5/3. So we will show that by highlighting the number line all the way to the right, which goes towards positive infinity. That just says there is no largest number that x can equal. It is unbounded, and we represent that idea with positive infinity. The other way that we're going to represent that set of numbers is what we call interval notation. We're going to talk a lot about this in the video, but to start off with, we are going to write down the smallest number that x can be, which is 5/3. Now, because 5/3 isn't included, we use a parenthesis, then a comma, and then the largest number. Well, there's no largest number. We represent that with infinity, and always a parenthesis with infinity or negative infinity. We will talk a lot more about interval notation in the video lecture and the practice problems and the assignment.